Okay, so I'm just going to assume that if you're watching this video, it's because you want to see more examples that involve the fundamental theorem so that you don't get tripped up on the stuff that might pop up in class. And so I'm just going to pick up right where this left off. Let's find the integral from, I don't know, 1 to maybe 9 of the square root of x dx. Now, so we're all clear. There's 1, there's 9. We're interested in this area. What does the fundamental theorem tell us? It tells us that we find some antiderivative, evaluate at 9, evaluate at 1, and subtract the answers. Well, what's the antiderivative of radical x? Well, radical x is x to the 1/2, so the power rule says that we increase that power by 1 and then divide by the new power. So we subtract what you get when you plug in 9 and what you get when you plug in 1. Well, plugging in 1 is easy. Plugging in 9's a little more difficult. You got to remember that this means take a square root, and that means cube the result. So square root of 9 is 3. 3 cubed is 27. 2/3 of 27 is 18. And so you get 17 1/3, 52/3. That's the area bounded by radical x between 1 and 9. Okay, again, it's an antiderivative, sub, and subtract, and then the rest is arithmetic. Make it a little bit tougher. Let's do the integral from 1 to 3 of 3x minus 2 times x minus 4 dx. I'm going to use this opportunity to remind you that there is no product rule for integrals. There's none. And so to do this, we have to multiply those all together. 3x squared minus, oh, that's not 10. That's not 10. Come on, YouTube guy, right? Like that. So what's this going to mean? We're going to find an antiderivative. We're going to substitute 3, substitute 1, and subtract the answers. What's that antiderivative? Well, the antiderivative of 3x squared is x cubed, and the antiderivative of 14x is 7x squared, and the antiderivative of 8 is 8x. So we're going to substitute 3, we're going to substitute 1, and subtract the answers. 3 cubed minus 7 times 3 squared plus 8 times 3. 1 cubed minus 7 times 1 squared plus 8 times 1. So that's what? 27 and 24 is 51. 51 minus 63 is negative 12. And then 1 and 8 is 9, minus 7 is 2. That's wait a minute, how can that be? Well, I'll tell you how that can be. What does this graph look like? Looks like this. There's 1. There's 3. This area is all below the x-axis, and so it corresponds to a negative integral value. There's a negative integral value because our area is below the x-axis. All right, I'll go one more. Let's do the integral from 1 to 2 of 1 over x squared dx. Nothing fancy here. Nothing fancy here. The temptation is to think that this is natural log because it's a 1 over, but it's very not. It's very not. This is x to the negative 2. So when we go to find an antiderivative, power rule says we add 1 to the power and then divide by that new power. right? Or we could simplify. This is just -1. This is 1 over x from 1 to 2, which means we substitute the 2, we substitute the 1, and we subtract those answers, and that turns out to be 1/2. Does that make sense? Arguably so. It's not a lot of area there. It's not a lot of area there at all. I mean, if this is a 1 by 1 square, yeah, I could believe that. Sure, I could. I can believe that. So each time we find an antiderivative, we substitute, subtract the answers, and that gives us the value of the definite integral. Hope these are helpful to you. I'll see you when we gather.